transient simulation program. Welcome to a short video on the features of LiqTHERM and LiqSurge. LiqTHERM is a steady-state simulation program, whereas LiqSurge is a transient simulation program. LiqSurge requires input from the results of the steady-state LiqTHERM model. First of all, we're going to look at a test pipeline and perform a steady-state simulation using LiqTHERM. So let's take the test pipeline that you see here. It's a 60-mile pipeline, 18 inches in diameter, and it has one pump station at the beginning called Harvard, and the terminus is Yale. We're looking at transporting diesel at the maximum flow rate possible, so we start off with 5,000 barrels per hour flow rate, and we'll let the program calculate the maximum flow rate. We have one pump station at the beginning. We also want to point out that we have a valve, a gate valve, pretty close to the end of the pipeline, which we will use for simulating the valve shutdown in LiqSurge. Okay, with this information we're going to run the steady-state analysis. So let's go ahead and run the simulation. We'll use the pump curves that are built into this model and calculate the maximum flow rate under isothermal conditions. Because we're pumping diesel, we don't need any thermal analysis. Okay, this gives us a maximum flow rate of 6,144 barrels per hour, and we'll look at the steady-state temperature profile and pressure profile. Temperature 60 degrees is isothermal, and the pressures vary from 720 at the beginning down to 50 psi at the terminus. So it's pretty close to the MAOP, maximum allowable operating pressure. Now this steady-state result is automatically saved into the TOT file for this pipeline. And the transient model will take that TOT file and use the information on the pipeline and the valve and the pumps. So under the transient menu on LiqTHERM, we have two items: create transient input data. When you click that, it'll start creating the necessary input data from the LiqTHERM data and put that information into the TOT file, which is going to be used in LiqSurge. The next step is to run the LiqSurge model. If you're licensed to run LiqSurge on this computer and you have installed LiqSurge, then we should be able to locate it and launch LiqSurge directly from LiqTHERM. Let's do that. It asks you for the path of LiqSurge program. Go ahead and browse. You should be able to locate the LiqSurge program and click OK. That will launch the LiqSurge transient model. In a few seconds here, should be able to get the opening screen for LiqSurge. Let me adjust the size of the window and bring it up here. Increase the size of the window a little bit. Okay, this is the opening screen for LiqSurge, which is a liquid pipeline transient simulation model. Like I said before, it takes the TOT file used in LiqTHERM as an input to the LiqSurge model. So let's open the file that we used. In this case is test pipeline 2009. That's the TOT file. As soon as you open that, the steady-state results from LiqTHERM are displayed in the opening screen of LiqSurge. LiqSurge also has several other menu items on here. We'll look at some of these. Let's look at the pipeline. It takes the information from the TOT file that LiqTHERM used and displays it here. There's three columns of data that I've already filled in: Poisson's ratio and Young's modulus, 0.3 for steel, and the Young's modulus is 29 million psi, and the anchor type is 2 for a buried pipeline. So most of this information is taken from the TOT file. We provide the additional three columns of data that LiqSurge requires. Pump stations: Harvard, located at 0, and that's the combined pump curve for the Harvard station. Liquid its diesel properties, and we have to add or supply two additional pieces of information: the bulk modulus and the vapor pressure, which LiqSurge requires. Valves: there is a valve at the end of the pipeline, 16 inches in diameter, and then we specify the transient. We're going to say this valve is initially open, initial state is 1, final state is 0, it's closed. We're going to close it in 10 seconds, and the transient is going to start at time 0. We can ignore these last two columns for right now. Now the pump transient, basically you specify the suction control pressure for the pump, suction trip pressure, a discharge control pressure, discharge trip pressure, and a check valve on the discharge side, and we can ignore the rest of these things because these don't pertain to a valve transient. Well, since in this analysis we're looking at a valve closure and not a pump shutdown. Okay, I think we have all the information we need here. Go over to calculate to run the simulation. There's a title, here's the input file, and the output report is going to be contained in the transient format or TRN file, which is going to be a text file. We're going to simulate the valve closure for 200 seconds, and we're going to customize the report by saying that we need the project description, we need a case number, simulation, we need the steady state data, and just the maximum pressure summary is all we need right now. So go ahead and click OK. This information, we're ready to run the transient simulation. There it is. We got the LiqSurge liquid pipeline transient simulation report, and it describes the steady state flow, the liquid properties used, the pipeline profile data, initial steady state conditions that came from LIQTHERM, and the pump station data, the valve data, and some calculated constants in the transient analysis. Now the time step reports, we start off at time t equals 0, basically the flow rates and the pressures at time 0, and then we're going to jump to the maximum pressure summary. This shows at the end of the simulation time we have obtained this table of maximum pressures at various points along the pipeline. You'll see the MAOP listed along with the maximum pressures reached at these points along the pipeline, and it shows the percentage of MAOP. In this case, the highest pressure occurs around 102% maximum, up close to the beginning of the pipeline. And at the end of the line, the pressures are all within less than 100%, as you can see here. Now we'll look at some graphs. There's a maximum pressure graph, a minimum pressure graph, and then you can do a dynamic animation. So here's a maximum pressure graph showing the maximum 110% MAOP line, 100% MAOP line in green, and a brown line that shows the maximum pressures, and the blue line that shows the minimum pressures reached during that 200-second simulation. We can also do a dynamic animation. This dynamic animation basically shows how the pressures vary along the pipeline during the 200 seconds of simulation, starting with valve closure at time 0, and the valve closes in 20 seconds. So let's start. Initial hydraulic gradient, and here's the time. As it approaches the 10-second valve closure time, you'll see the pressure at the terminus start increasing, and then that'll generate the surge pressure wave which travels upstream. Pretty close to 10 seconds now. Should be seeing the pressure rise. There it is. So that pressure wave would travel from the downstream end to the upstream end, goes up to the pump station, then it doubles back, and it'll be oscillating back and forth with the valve closed. And if the pressures are high enough to shut down the pump, then the surge pressures will travel back and forth until it stabilizes after a very long time. We're at 20 seconds right now, and the simulation we're performing is for 200 seconds. I'm going to go ahead and stop this right now in the interest of time, and let's look at some of the other things here. You can look at the file menu and say save the graph as some format, some JPEG or GIF format. And if you look at the report, you can look at the transient report, and you can see that you can save the formatted report and so on. So this is a short summary of LiqSurge and how it can be launched from LIQTHERM. The important point is that the LiqSurge model requires the steady state output from LIQTHERM. So the pipeline has to be built and modeled in a steady state condition for the particular flow rate in LIQTHERM, and then that TOT file is then fed into the LiqSurge model. So I hope this gives an overview of how LiqSurge simulates a pipeline using results from LIQTHERM, and thank you very much for your attention.